So I'm going to go over this question. It is known that the weights of male Persian cats are normally distributed with mean 6.1 kilograms and variance of 0.5 squared. 0.5 squared. So this question is a little bit challenging because normally for a normal distribution you're given the mean and the standard deviation. However, for this question we're not given the standard deviation, we are given the variance. Now the variance simply is the standard deviation squared. We call this the variance. As we know, this is the standard deviation and this is the mean. But look at the relationship between the variance and the standard deviation. To get from one to the other, we either square root or square. However, this question was not too difficult because rather than giving you the variance, and the variance actually should be 0.025, it's actually given you the standard deviation squared. So what we need to assume is that the standard deviation is going to be 0.5 because the variance is 0.5 squared and the mean is 6.1. The first thing it says to do is sketch a diagram. So this is 2 marks. First thing you need to do is draw a bell curve where it's rather symmetrical. You then need to identify where the middle is and call this the mean. You then will numerically write what the mean is on the question. So our numerical answer for this is clearly going to be what we wrote above, which is 6.1. You're then going to represent, say, a jump of 0.5, which is our standard deviation. So you could draw an arrow and represent 0.5. You could then also identify what 6.1 plus 0.5 is going to be. That would be 6.6. And then you'd say this is a one standard deviation jump. And then you could go 0.5 the other way, which is going to be 5.6. So that's really easy. Question B. Find the probability of proportion of male Persian cats weighing between 5.5 and 6.5. Now this is easy. What you have to do is you have to go onto the calculator. On the calculator we're going to go onto the distribution menu. We're going to go onto normal CDF. On the normal CDF menu, what we need to do is press enter, and that's our answer. So the answer to part B is going to be 0.67307, and if you're not sure in the exam, just leave it to a few decimal places, and then if you want to round it, of course round it to 3 significant figures. Now, what we're going to go over next is part C. A group of 80 male Persian cats are drawn from this population. And then it says, determine the expected number of cats in this group that have a weight of less than 5.3. So, first thing we need to think of is that it says a weight of less than 5.3. So this is to do with bounds, which is great. And we can determine what the bounds are going to be, like the previous question. If it's less than 5.3, it's going to be this sort of part of the graph and smaller. You can see that's going to be quite a small probability, which is going to be less than 1. Definitely less than 1, but definitely also less than 0.5 because it's less than half the graph. So what you do is on your calculator, we're going to repeat the same process, second distribution, and we're going to go on to normal CDF. Then we're going to press the upper and lower bound. So the lower bound first, -1, this E above the commas, E99, comma, 5.3, which is the upper bound. Then the mean and the standard deviation as before. So our answer is going to be very small, 0.05479992. That looks right in terms of the drawing we've drawn. And you can tell it's going to be quite small because 5.3 is quite significantly smaller than 1 standard deviation smaller than the mean. But the question is not asking that. It's asking for an expected number. This here is a probability. So how do we convert a probability into a number? Well, what you need to do is look at the previous part of the question, and it says the fact that we were looking at a group of 80 male Persian cats drawn from this population. So if there's 80, our expectation, if it ever says expected in a question, you need to times. So we're going to do 80 multiplied by the probability, 0.05479992. It's important to keep as many decimal places as possible. We've already got it in the calculator, so we're just going to times that by 80, and then we get 4.3. So I'm going to write 4.383. Now, because this is a discrete variable, i.e. that it needs to be exact because we're talking about numbers of cats, we then need to round this. So we're going to round it down, so approximately 4 cats. Now, we want to go over question D and question E. It is found that 12 of the cats weigh more than X kilograms. Estimate the value of X. Now, this question is a lot more challenging. And the way we're going to do this question is by thinking about all the topics we know to do with normal distribution. This question is clearly going to be an inverse question, but you might not have realised that straight away. So what we're going to do is we're going to draw a quick picture. It's estimated or found that 12 of the cats weigh more than X kilograms. So we know the whole population is 80 cats. So 12 weigh more. So we're going to go to the right-hand side to draw our line. We're going to have X. And because we know the mean, as before, was 6.1, we're expecting the cats to weigh more than 6.1. Now, normally with normal questions, you are given 2 bounds. And you're asked to find a probability. Now, in this question, because we're not actually given the bounds, all we know is the maximum bound, which is going to be infinity. We don't know this bound. This means that it's going to be an inverse normal question. Now, if it's an inverse normal question, what we're going to focus on is the following. We are going to have a look at the probability. So you're either given 2 bounds to find the probability, or you're given the probability to find the 2 bounds. So we look to the question and we ask ourselves, can we see a probability? No, but it does say that 12 of the cats are in this area. So what you need to do is use the 12 and 80 together. So we know the probability of picking something over X kilograms is going to be 12 over 80. Now that's the magic number, magic fraction, but this makes this question quite difficult. So with the inverse normal, you are going to do the same as before, but we're going to type inverse normal. What you would then do is write the probability. You could write that as a decimal or as a fraction. So 12 over 80, comma, then you'd write the mean, and then you'd write the standard deviation. So that's what we're going to do next. We're going to go onto the distribution menu. We're now going to go on to number 3, which is the inverse normal. We're going to write the probability, which is 12 divided by 80. We're then going to write the mean, which is 6.1, then the standard deviation, which is 0.5. Then we're going to press enter. You can see I've made an error here, and it specifically is additional dot. So it's important to go slowly if you're prone to making mistakes like me. Let's have a go again. 12 divided by 80, comma, 6.1, comma, 0.5. Close brackets. There we go, 5.58. So our answer is going to be 5.581783331. And this can be rounded to 3 significant figures because this is representative of this X. But you can see this doesn't sound right, because if it was 5.5817833, this would be this side of the graph. So what you need to do is, if it is to do with an inverse normal question and your calculator is not in classic mode, you have to take the complement of 12. So you have to take the rest of the graph. You always should focus on the left-hand side of the graph if your calculator doesn't have if it doesn't have classic mode. So we're going to try this again. What we'll do is inverse normal, and we're going to do the following. Instead of 12 over 80, we're going to do 80 minus 12, which should give you 68, I believe. That's correct, over 80. And that means it's going to be focusing on this side of the graph. This side of the graph has a probability of 68 over 80. And then it's going to discover this upper bound. You should always focus on the left-hand side if your calculator is like mine and it's not so technological. Now, what we will do is we'll type that in the calculator, second distribution. We're going to go onto normal CDF. We're going to go over 68 over 80, comma 6.1, comma 0.5, and our answer is going to be 0.363. But you can see that I've put normal in rather than inverse normal. So let's go again. 68 divided by 80, comma 6.1, comma 0.5. Press enter. Our answer is going to be 6.61821669. That sounds much better. It's bigger than the 6.1 and it's towards this side or the right hand side of the bell curve. That is our answer. So rounding that answer, we're going to get 6.62. This means it's found that 12 cats are more than 6.62 kilograms. You could then check your answer. I'm just going to show you really quickly. Go second distribution, and we're going to go forwards with the problem rather than backwards. We are now going to write the lower and upper bound. So we're going to say the lower bound is 6.62, and rather than rounding it, I am going to write it out in full because the answer will be more accurate. That's our lower bound. Our upper bound, as always, is going to be infinity because we're talking about something being greater than something. Therefore, the upper bound must be infinity, 1e99. Then we're going to write our mean. And then last but not least, we're going to write our standard deviation, which is 0.5. Then we press enter, and you can see the answer is 0.15. And that works really well because that says it's 15%. And we know that 12 over 80 is also 15%. Now, this is only a hack if you want to double check your answer is correct.